So we talked about matter, and we said matter is stuff, right? Anything that has mass takes up space. Well, what is energy? What's the middle school or high school definition for energy? Anybody know? That's right, the ability or the capacity to do work. And energy is a conserved thing. Can you tell me different types of energy? Kinetic energy, for sure, yeah. Potential energy, so that is energy that is stored, potential energy, right? So this pen has some potential energy right here, right? Because of its height. Right. Now it's got slightly less. So it moved, right? So that potential energy was converted to kinetic energy, the energy of motion. Now it's on the ground, so it has a lower potential energy than it had before, right? Potential energy is stored energy. Kinetic energy is energy of motion. So if we think about chemistry for a minute, kinetic energy we kind of understand because molecules are always in motion, right? Gases, for example, are flying around banging into you and everything in this room right now, and so they have some kinetic energy. Where's potential energy in chemistry? Before reactions occur. Yeah, so anytime we convert reactants into products, right, we turn A into B, right? That can be whatever you want. So nitrogen into ammonia or whatever it's going to be. There's an energy that gets either absorbed or released in that transformation process. The reason for that is that you've got an atom, you've got another atom, and they're bonded together, right? Electrons are in there, and they're either transferred or shared or however that works, and they're stuck together. Well, that chemical bond is stored energy, right? And so what happens in a chemical reaction is we take apart these atoms over here, and we rearrange the Lego blocks and we put them back together in some other configuration over here. Well, now this configuration has a different amount of stored energy. So we had some stored energy over here. We got a different amount of stored energy in the products. And that difference is the energy of the reaction. Okay? So that is where we store energy in chemistry, is in chemical bonds. Okay? So that kinetic and potential are kind of like the broad stroke energies. What are some other types of energy? Electrical energy. Where does that electrical energy come from? Well, in Alabama, we don't have a lot of options. It's either some coal plant somewhere or some hydroelectric dam somewhere, right? So this one, I'm not sure, honestly, what we're on in Jacksonville, Alabama. So let's go through that process for just a second, all right? So I'm from Gunnersville, Alabama, right? We have an electric dam, hydroelectric dam in Gunnersville, Alabama. So how does that work? So we got water up here, we got water down here, and we use that height difference in the water. So we flow the water from high to low. It turns a turbine, right? So that's mechanical energy, right? We're using gravitational potential energy, turning it into mechanical kinetic energy, which then turns a generator, which makes electrical energy that can then power these lights, right? So there's all these different types of energy that can be transferred from one form to another, right? Energy is a conserved thing. You can't create it or destroy it, but you can change its form, okay? Or another way to say that is the total amount of energy in the universe is constant, right? So can't create it, can't destroy it, but we can convert it from one type to another. We talked about kinetic and potential energy. We talked about electrical energy. There's thermal energy. That is the primary place that we see kinetic energy in chemistry, is through the random motion of atoms and molecules, all right? Anything that's sitting has a temperature, right? Its remote control has some temperature. It's whatever the room temperature is right now, right? But temperature is the measure of the average kinetic energy in a thing, right? So your body temperature is 98.6 degrees Fahrenheit, hopefully. What does that mean? Well, that means that the atoms and molecules in your body are vibrating, oscillating at some speed, right? If you're 104, you should probably go to the doctor. If you're 104, that means that they're oscillating and vibrating faster, right? They're moving faster. We talked a little bit about chemical energy. It's a type of potential energy that's all about how particles are put together in a system, how atoms are bonded together. So the base unit of energy is the joule. Another very common unit of energy, one that you'll see a lot in biology, if you take biology classes, is the calorie. All right? Calorie is defined as how much energy does it take to raise the temperature of a gram of water by 1 degree C. Unit that you guys are familiar with is a calorie with a capital C, and that's like a kilocalorie, or 1,000 little calories. That's the food calorie, right? So if you look at a nutrition fact and it says 240 calories, it's this calorie with a capital C, which means kilocalorie. Okay. We're also somewhat familiar with the kilowatt hour. If you've ever seen a power bill, a house power bill, they're measured in kilowatt hours. So it's probably gone up a little bit since I created these slides, but roughly 12 cents per kilowatt hour is the cost of electricity in the United States, or at least in Alabama right now. So these are different ways that we can measure energy, and there's more ways than this, but these are the ones that we're familiar with. So now we can make some conversions between the different types. So 1 calorie, little calorie, is 4.184 joules, and this is an exact number. Infinite significant figures in that. 1 capital C calorie, or also referred to if you're in a European country as a kcal, that's 1,000 calories. Okay, and then a kilowatt hour is 3.6 million joules. In chemistry, we express energy in terms of joules and kilojoules most often. Okay, those are going to be the units that we use. Most often kilojoules, but some things are expressed in joules. So here's a good question. Got a candy bar at 225 calories. How many joules does that contain? How many joules of energy? So how would we approach this problem? What would we do? Well, the general problem-solving approach says that we should figure out what we're trying to find. So what's the thing we're trying to find? Joules. And what is the thing that we start with? This 225 calories. Now, do I know a direct relationship between the two? I don't think I do. But I do know like a two-step way to get there maybe, right? So my approach would be start at cal, trying to get to joules. What can I do? What can I go to that can get me closer to joules? Sure. Yeah, lowercase cal, and then from there I can go directly to joules, right? So what's the conversion factor that we use to go from big cal to little cal? So yeah, so there's 1,000 little cal and 1 big cal. All right, now what's the relationship over here between calories and joules? 4.184 joules is 1 calorie. All right, so those are my conversion factors to use. So now we say 225 cal. There's 1,000 little cals and 1 big cal. And then there's 4.184 joules in 1 little cal. Check the units. Big calorie cancels, little calorie cancels. I'm left with joules. And then it's just a little bit of math. 225 times 1,000 times 4.184. And so what is the answer? 941,400, or 9.41 times 10 to the 5 joules, with the right number of sig figs, because we only have 3 here, so our answer can only have 3. All right, here's one for you. Let's convert 95 kilowatt hours to capital C calories. All right, so what was the step here? We did what, 95 kilowatt hours. What's the first conversion factor? 3.60 times 10 to the 6 joules over 1 kilowatt hour. And then what's the next step? So 4.184 joules is 1 little cal, and then 1 big cal is 1,000 little cals, right?